Okay guys, so now let's start with the second problem. Okay, so this is the given figure. Okay, so this is a given truss. So this is A, B, C, D, E. So there are totally 5 joints in the given truss. So now we know that what's the first step? The first step is to find out the reactions, that is using summation h equal to 0, summation v equal to 0 and moment about any point equal to 0. Now as you can see from the triangle or the truss, this is equilateral triangle, right? 60 means this is also 60, so all the angles are 60 and all the sides are equal, so this is equilateral triangle. Similarly, if this is 60, this is 60 and this is also 60, again the sides are 3 meters, so again all the angles and all the sides are equal. Again this is equilateral triangle. That means this is also equilateral triangle, this is also equilateral triangle. If this is 60, if this is 60, then what is the remaining angle here? It is also 60. So again this is also equilateral triangle. So the given truss consists of 3 equilateral triangles, right? So now the first step is to find out the reactions using summation h equal to 0, summation v equal to 0 and moment about any point equal to 0. So the first condition is summation h equal to 0. So when we use summation h equal to 0, now we can see here joint A, right? The joint A consists of the hinge support, right? This is hinge support. So we know that at hinge support there exists one vertical reaction and one horizontal reaction. So we can write here one vertical reaction, we'll call this as VA, one horizontal reaction, we'll call this as HA. And at joint D there is a roller support. So roller support, which means at roller support we have only one vertical reaction, so we'll call this as VD, right? Now first condition, summation of horizontal forces is equal to 0. So HA, and there are no horizontal forces, that means HA is equal to 0. Second condition, summation of vertical forces is equal to 0. So plus VA plus VD, because they are acting vertically upwards. So plus VA plus VD minus 2 minus 4, that's equal to 0. That implies VA plus VD is equal to 6. VA plus VD is equal to 6. Now third condition, moment about any point equal to 0. So I will consider moment about point A. Okay, so now first we'll consider VD force. So we know that moment is force into perpendicular distance. So VD into 3 plus 3, that is 6 meter. So VD into 6 and the effect is anti-clockwise. So minus VD into 6. So minus VD into 6. Next we'll consider 4 kilonewton force. So again force into perpendicular distance. So here the force, this is 4. Now we want distance from this point, that is from this point to this point, right? Force into perpendicular distance. So we know that it is a equilateral triangle. That means if this is 3 meter, this is the crown. So if you draw perpendicular from the crown, it will cut exactly at the midpoint of the base. That means if this is 3 meter, this is 1.5 meters. Okay, so from here to here this is 1.5 meters. So 4 into 1.5 plus 3, that is 4.5. So 4 into 4.5, this is clockwise, so we'll write positive sign. Next, similarly, plus 2 into 1.5, that's equal to 0. That implies VD is equal to 3.5 and VA is equal to 2.5 kilonewton. This completes the first step, that is finding out the reactions. Next we'll move to the second step, that is method of joints. So we know that when we start method of joints, we need to consider the joint with least number of unknowns, right? So now we can see here if you consider joint B, there are three unknowns, C 3 unknowns, and at E 1 2 3 4 unknowns. So we can't consider B, C and E. Either we have to consider joint A or joint D. Okay, so first I will consider joint A. Right? First I have considered joint A. So we know that at first we need to assume all the members or all the forces as tension forces. Tension forces means acting away from the joint. Okay, so if you consider joint A, so I have drawn here joint A. So FAE acting along positive x-axis, FAE acting along positive x-axis, FAB acting in first quadrant, right? Angle of inclination is 60 degree with horizontal, angle of inclination is 60 degree with horizontal, and HA is there. So you can show here HA, or if you not show, that is also okay, because HA is equal to 0 and VA acting, and the VA is acting vertically upwards, so VA is acting vertically upwards. So FAB can be resolved into FAB sin 60 because it is acting in the first quadrant, so both are positive. So this is FAB cos 60, FAB sin 60. Next we have to use the condition in method of joints. We have to use only summation V equal to 0 and summation H equal to 0. So first I will use summation V equal to 0. So VA acting vertically upwards, so plus VA, right? FAB sin 60 acting along positive axis, so plus FAB sin 60, and there are no vertical forces, so that's equal to 0. So VA plus FAB sin 60 is equal to 0. That implies FAB is equal to minus VA divided by sin 60, that is equal to minus 2.89. Here we got the answer in negative, that means the force is compression. So we write FAB is equal to minus 2.89 compression force. Right. Next condition, summation of horizontal forces is equal to 0. So horizontal forces is FAE are acting along positive x-axis, so plus FAB are acting along positive x-axis, so plus FAB cos 60, and there are no horizontal forces, that's equal to 0. Even though HA is there, but HA is equal to what? HA is equal to 0. So we'll write only FAE and FAB cos 60. So FAE plus FAB cos 60 is equal to 0. That implies FAE is equal to minus FAB cos 60. And what is the value of FAB we got? We got FAB as minus 2.89. So FA is equal to minus sign, we'll keep it as it is. In FAB we will write minus 2.89. So minus in the bracket minus 2.89 cos 60. The answer we got is plus 1.44 kilonewtons. Plus, that means this is tension force. So FA is equal to 1.44 kilonewton, which is tension force. Okay. Now we have finished joint A. Now we will go to joint D. Okay. There are only two unknowns here. So let's go to joint D. Once we go to joint D, again similarly, at first we need to consider all the forces as tension forces. Tension forces means acting away from the joint. Okay. Now see here, this is a joint D, right? So this is DE, positive acting along negative x-axis. FDC acting in second quadrant, angle is 60 degree with horizontal, and there exists one vertical direction. We'll call this as VD, right? The same I have drawn here. So VD acting vertically upwards. FDC, you can see here, FDC acting in second quadrant, angle of inclination is 60 degree with horizontal. This is FDE. So FDC can be resolved into two components, FDC sin 60 and this is FDC cos 60. Now summation, again the same condition, summation V is equal to 0. That means summation of vertical forces is equal to 0. VD acting vertically upwards, so we'll write plus VD, and FDC acting along positive y-axis, again we'll write plus FDC sin 60 is equal to 0. That implies FDC is equal to minus VD divided by sin 60. The answer we got is negative, that is minus 4.04. That implies the force is compression. So we'll write FDC is equal to minus 4.04 compression. Next condition, summation of horizontal forces is equal to 0. So horizontal forces, FDE acting along negative x-axis, so minus FDE, FDC cos 60 acting along negative x-axis, so again we'll write minus FDC cos 60 is equal to 0. So FDE is equal to, so we'll write here, so minus FDE, first you can write here, see here, minus FDE is equal to plus FDC cos 60, right? That implies FDE is equal to minus FDC cos 60. FDC is minus 4.04 again, so FDE is equal to minus into minus 4.04 cos 60. The answer we got is plus 2.02 kilonewton. Plus sign indicates FDE is tension force, that is FDE is equal to 2.02 kilonewton. Next we have finished joint A and joint D. Next, either we have to consider joint B or joint C. Okay, we can't consider joint E because there are more number of unknowns. So I will go for joint B. Now if you consider joint B, okay, now 2 kilonewton acting vertically downwards, right? So I will write here, this is 2 kilonewton acting vertically downwards, right? Now what I said, when you consider a joint, we have to assume that each force is tension force. Tension force means acting away from the joint. Now FBC, so this is FBC, so this is FBC, right? Now FAB, tension force acting away from the joint, so this is a joint, so this is a joint acting away from the joint, so it is acting in third quadrant. So I will write here FAB or FBA, both are same. Angle of inclination, if this is 60, that means if you draw horizontal here, this is 60, this is also 60 because alternate angles. So angle here is 60 degree, right? Similarly, this is FBE, this is FBE, again angle here is 60 degree. Any other force? We have considered FBC, we have considered FAB, we have considered FBE, we have considered 2 kilonewton force, right? The same I have drawn here, the same I have drawn in your notes. You can see here. Now again we have to use the same condition. First condition, summation of vertical forces is equal to 0. So 2 kilonewton acting downwards, so minus 2, right? And FAB acting in third quadrant, so vertical component is FAB, what? This is 60 degree, so here is the cos, here is the sine. 1 second. Now this is FAB, right, acting in third quadrant. That means this is FAB cos 60, right, and here you will get FAB sine 60, right? Now FBE is acting in fourth quadrant. That means this is the horizontal component. You can see here I am drawing with the green ink. So this is FBE cos 60 and the vertical component is here. This is FBE sine 60, right? Okay, so now we have to use the condition summation of vertical forces is equal to 0. So vertical forces is 2 kilonewton acting along negative y-axis or vertical downwards, so we'll write minus 2. So this is minus 2. Now FAB sine 60 acting along negative y-axis, so minus FAB sine 60, minus FAB sine 60. Similarly, minus FBE sine 60 is equal to 0. So minus FBE sine 60 is equal to plus 2 plus FAB sine 60 minus FBE is equal to 2 as it is. FAB is what? FAB we got as minus 2, right? FAB we got it as minus 2.89. So here it is 2 minus 2.89 sine 60 whole divided by sine 60. So FBE 0.58, we got positive sign. So FBE is equal to 0.58 tension force. Similarly, summation of horizontal forces is equal to 0. So FBC acting along positive x-axis, so plus FBC, FAB acting along negative x-axis, minus FAB cos 60, FBE cos 60 acting along positive x-axis, plus FBE cos 60 is equal to 0. Again, putting all the values, we got FBC as minus 1.735 compression. Here remember, FAB you have to put as minus 2.89 and FBE, this is in the bracket plus 0.58. If you solve this, you will get FBC as minus 1.735 compression. Right, now we have found almost all the forces, right? That means first we have considered joint A. We got the force in FAB, FAE, right? Next we have considered joint D. We got the force in FDC and FDE. Now next we have considered joint B. So we got the force in FBC and FBE. Only the force remaining here is FCE. So to find FCE, either we need to consider joint E or joint C. So I will go for joint C. You can also use joint E. Okay. So I used here joint C. So again the same procedure. We'll draw. First we'll consider all the forces as tension forces. Tension forces means acting away from the joint. So this is FCB, this is FCE, this is FCD, and 4 kilonewton acting vertical downwards. Angle is 60 degree. If you use summation of vertical forces is equal to 0, 4 acting vertical downwards, so minus 4. And this is FCD, right? FCD means acting in fourth quadrant. So vertical component is this one. This is FCD sine 60. So this is minus FCD sine 60. This is FCE. This is 60 means again here FCE sine 60. FCE sine 60. So minus FCE sine 60. So we want the force in FCE. So FCE sine 60 is equal to plus 4 plus FCD sine 60. Put the values. So FCE is equal to, we got it as minus 0.578 kilonewton. So FCD what we got? 1 second. FCD is minus 4.04 compression. So we need to put in FCD as minus 4.04. This is minus 4.04. So FCD we got it as minus 0.578 compression. So after this we have found all the forces in the given truss. So After that, we'll prepare a table like this. So these indicate members. This is force, this is nature. AB, AE, seconds here. AB, AB, AE, AE. Next, DC, DC, DE, DC, DE, BC, BE, BC, BE, and CE, CE. We'll write the values. If the sign is negative, we'll write compression. If the sign is positive, we will write tension. This completes the problem.